Thank you everybody for joining. Today's session is going to be on access management, or specifically, to give it a different term, authorization. And we're going to be covering how you can use Cedar policy language and Amazon Verified Permissions to do that. I'm Julian Lovelock. I'm the product manager for Amazon Verified Permissions. I'm going to be joined today by my colleague Abhishek, a fellow product manager, and Daniel, AWS hero for security, who's going to be talking to us about his experience using Amazon Verified Permissions at Algotech International, and by Justin McCarthy, co-founder and CTO of StrongDM. We're going to start with a short introduction to the Cedar policy language, and then segue into Justin talking about how he's used Cedar with his company StrongDM. We're then going to introduce Amazon Verified Permissions, which is a hosted service to store and evaluate Cedar policies. And then Daniel's going to come on stage and talk about how his company worked with Simply Business to implement an authorization solution in the insurance world using Amazon Verified Permissions. And then we're going to close out with a short demo of a new feature that we've launched that we're excited to share with you. So, authorization, what is it? Not to be confused with the counterpart authentication. So authorization is essentially the set of rules that describe what a user of an application is permitted to do, and the enforcement of those rules. And why is it so important? Well, from the CWE's report, 4 out of the top 25 most dangerous software weaknesses identified by CWE related to the management and application of authorization rules. So you're in charge of securing the IT domain of a large, complex organization. What's your challenge in regards to authorization? Well, your challenge is that you have hundreds, maybe even thousands of applications across your domain that are used by employees and customers to access enterprise resources. Those resources are often data, but they may be services, they may be smart devices, they may even be physical resources like a room or a piece of equipment. And each of those applications typically is going to manage permissions on its own and make its own authorization decisions. So whereas you may have centralized the authentication process and reverted back to a single IDP for authentication to manage user identities and user credentials, authorization is still being done locally across hundreds, maybe thousands of different applications. And this has impact from the perspective of cost, and that big cost element is auditability. If you're running an audit to try and figure out what all of these applications allow, that's an expensive process across hundreds, maybe thousands of applications. It has a risk component to it because protecting those resources where each application has its own view of who's allowed to access them is complex and open to loopholes. And it introduces friction into the building of new applications, because every new application that you build, you need to think about designing a permissions and authorization model for that new application. So we wanted to set about solving this problem. And the first step in that journey is to introduce a policy language that can be used to encode the rules for authorization, to write policies about who is allowed to do what. And we called this language Cedar, and we published it as an open specification. So the Cedar language specification is openly published, and not only that, we open sourced an SDK that developers can use within their applications to evaluate Cedar policies and get authorization decisions. So why invent a new authorization language? There are existing authorization languages out there. Why did we feel the need to invent a new one? Well, as always, we worked back from what our customers told us they wanted. And the first thing that they told us was that they wanted a policy syntax that is easy to understand. I do appreciate the irony of using a word like ergonomic to try and convey simplicity of understanding, but they wanted a policy language which is ergonomic, easy to understand. So take a look for a second. Many of you have never seen Cedar before, I'm guessing. Take a look at the policy in the white box. Spend a moment. Can you figure out what that policy is saying? Hopefully, it's relatively easy to pass, even if you've never seen it before. The policy is saying that if you are an individual in the role of doctor, you can use the EMR application to view patient records and refer patients, provided that the patient in question has you as their primary care doctor. So hopefully the language is easy to understand, and it's designed as such so it's comprehensible to non-technical folks, including auditors and other people who need to understand what the rules are but don't have a background in programming. The second criterion was that it should be expressive. The language needed to be able to describe the different types of rules that organizations and individuals want to create policies for. And these include role-based access. You can see here, part of this policy is based on role membership. Is the individual concerned in the role of doctor? And part of this policy is based on attributes. Is the individual concerned the primary care doctor for the patient? So the policy language combines both RBAC and ABAC. It also needed to be safe. And by safe, I mean it needs to work every time, follow the spec every time, no bugs. And how did we achieve that? Well, we built a reference implementation of the Cedar algorithm in a reference model in a language that we could formally verify mathematically that this implementation does exactly what the spec requires it to do. And we used that reference implementation to generate literally millions of test case results, expected outcomes. So we then created a corpus of millions of tests that we can then run through the optimized implementation of the Cedar SDK to make sure that that optimized performance implementation does exactly what the specification says. And to our knowledge, this is the only authorization solution that has this high level of assurance. It also needs to be highly performant. If you're following the principles of zero trust, then you should be authorizing each and every action that a user does within your application. And so you're making millions of authorizations, potentially even millions of authorizations per second. So we tested the implementation of Cedar compared to other popular authorization policy languages, and it is indeed considerably faster than alternatives. Rego, for example, which is a commonly used alternative authorization system, Cedar runs evaluations up to 60 times as fast as a Rego evaluation. And lastly, the policy language needed to be analyzable. As your body of policies grows, you have hundreds, thousands of policies in your store, and you need to be able to analyze them and ask questions of that policy store. Which policies overlap? Which policies can never be applicable because they're contradicted by other policies? Which policies permit access to certain resources? So analyzability becomes a key requirement of a scalable, performant policy language. And so to summarize, to answer the question, why invent a new authorization language? Because we wanted to balance all of these requirements. So there are other languages out there, and again, Rego being a good example, that give a higher level of expressibility, but at the expense of these other criteria, such as safety, ergonomics, performance, and analyzability. So with that, I'm going to hand over to Justin, and Justin's going to talk about his experience as StrongDM using the Cedar policy language.
All right, so I'm Justin. I'm the co-founder and CTO at StrongDM, and as Julian introduced, we are going to talk about our use of Cedar and how it's actually been very good to us so far, and I'm going to take you through all of that in this talk. So first off, just a little bit about the company. So we've been around since 2015, and we've got customers really from every industry throughout the Global 2000, and a lot of what customers turn to us for are what has traditionally been called PAM, or Privileged Access Management. You know, our understanding of PAM is, especially in the context here of an authorization talk, is really about those actions. So as Julian just shared, what you're hoping to do is, in a zero trust architecture, in an authorize everything environment, is you're thinking about which are the most consequential actions that a user is potentially taking, and then you're producing an environment where each of those actions can be authorized with as much context and as much detail as possible. That's what we were seeking when we ultimately selected Cedar. We also like to anchor as many of our design decisions as possible in first principles, and to the extent possible, we like to think a little bit about history. So let's just think for a moment a little bit about the beginning. So in the beginning of software, maybe not the very beginning, but in recent history, you might remember that we had many applications that in fact had separate notions of authentication. So for N applications, we asked our users and all those constituencies to remember N passwords. I think I just want to congratulate everyone here and everyone that's part of the industry for solving this by achieving, through a few standards and a few popular implementations, a situation where single sign-on and unified authentication is now a basic assumption that I think we can all approach our work with. And so that was a real innovation and a great relief for many users. And actually that, of course, eliminated a whole class of potential exploitation that existed out there. But today, the situation that we're faced with is very similar, but now at the authorization layer. So in each of the applications that we all support, authorization is custom and proprietary to that particular application. And this is something that I think we can all hope through our work together over the next few years that we might end up with a similar story where we could ultimately hope to unify that authorization. But it's also pretty reasonable to ask, when we went through the standardization process and when we did unify authentication, why didn't we get authorization for free? They're almost the same word. Look at all those letters and comments. It says auth something. There's just that one letter difference. But somehow we didn't get it, okay? So let's ask ourselves why, when we solved authentication as an industry, we didn't get authorization for free. So let's think about what authentication is in some simple sort of form. So let's assume we have some secret material. In this case, we've got the idea of some asymmetric encryption. So maybe I have a private key that represents my identity or a particular session. The act of establishing that I'm authenticated could be as simple as a low-level cryptographic operation that simply verifies that essentially I'm holding the private key. Okay, because of all of the hardware optimization and software optimization, this is a very straightforward, very predictable operation that we're all familiar with, and we get a Boolean result. Is this user authenticated? That's something that I think we've all come to rely on. Now let's think about the authorization decision. And again, often I like to replace the word authorization with action. Is this action allowed? So thinking about that really fine-grained action, this particular button push or this particular command, what factors might we consider when making that decision about whether this action was allowed? So the first one we might consider is, of course, the who. That's going to come hopefully from the authentication. So who is involved? Who's performing this action? Continuing through the 5 W's, maybe the what. So what might represent a particular resource or a particular operation on that resource. You might even ask some sort of temporal question. Is it, can the user perform this at this particular time? You might have a concept of geography going into that authorization decision. You might even ask for some sort of justification to be attached to that decision or some workflow. Okay, you can see we've got 5 W's here, and this is already a much more rich, complicated question than simply verifying authentication. Okay. You might even say something about maybe the network transport, the TLS level or something like that involved in this action. So all of these components and more can potentially roll into that authorization decision. And when I look at a situation like this, I realize, gosh, there's a lot. This is a combinatorial explosion. We need some tooling, some intellectual tooling, and some software tooling to help give us leverage over this problem. Okay? And that's where we began our journey and our search for an authorization language. Okay. Of course, there could be multiple paths to authorization for StrongDM, and so looking at the prior art, there's a pretty common paper that anyone is going to find when they go looking for this question. This was obviously published by Google in 2019, and it established the notion of relationship-based model of how to encode permissions and evaluate them quickly. And because it's been proven at hyperscale, this is obviously a valid model. When we thought about this often called reback approach, what we found is while we were convinced that it was sufficient, it was not always as expressive as we'd hoped. So the simplified grammar that you see on the screen here, it can in fact encode any permissions relationship that you wish to have in your system, but we were missing that expressiveness. So next we reached for, perhaps we can concatenate an expression language of some kind. So we also considered another language from Google, the Common Expression Language. If we bring it together with reback, perhaps that's enough. But we kept searching. So Julian did talk about Rego earlier as part of the open policy agent. That was another strong contender, fairly widely adopted. It certainly did have much more expressiveness than, for example, reback alone. But we kept searching, and just thankfully, the Cedar team had recently published the language, and what immediately caught our eye was the readability. Okay, so internally at StrongDM, we find that writing Cedar expressions gets us thinking in the right direction. It gets us thinking about authorization in the right way, and in terms of what principle, what action, on what resource, and in what context. There's no way that you can write a Cedar expression without thinking those questions through. We find that to be a very productive way of working on any given policy set. Okay. The next property that we just loved was, of course, that it was performant. This is clearly in the design of the language and in the reference implementation. But we absolutely, in our own testing, found that some of the pathological cases with some of the other alternatives just weren't present in Cedar. So it had a huge reliability, very low variance, and very high throughput, which was just beautiful for our use case. The final note on machine reasoning and really all of the automated validation. This is essential as your policy set gets larger and larger, and you need to provide your customers with automated tooling for refactoring and changing the policy set. This was something that Cedar excelled at, and we're excited to build on top of that property as well. We were satisfied with our language choice, but we actually still faced a pretty tricky deployment question. Because the nature of our product demanded extremely low latency, extremely high throughput authorization. Okay, so the initial deployment architecture involved a network call over HTTP here in this case in this illustration, and that again was sufficient. It was going to give you the right answer, but it wasn't going to give us the latency and throughput levels that we required out of our system. Okay, so we looked at some alternatives, and we ultimately decided that what our product needed was an embedded native implementation in the same language that the rest of our product was built in. So as a result, our team put together the first implementation of the Cedar engine in the language Go, which for our purposes is now embedded inside of our proxy, which means we can perform authorization at wire speed with extremely fine granularity, and internally we just refer to this as microseconds, not milliseconds. And that's actually been a really, really powerful aspect of our embrace of Cedar. Thankfully, the language specification is open, and that means that our implementation is also open. So you can find and use the Cedar Go implementation today in the main Cedar organization on GitHub. All right, so let's look at a few examples of how this comes together in a production application. So an example here of the notion of a very critical operation inside of a common SaaS application. So in this case, the Microsoft 365 admin console. Within that console, it's possible to perform, in some cases, really important operations like adjusting someone's multi-factor requirements, or in this case, in this example here, updating the user's contact information, which might even include something like their email address. So in this case, we've got a policy constraint that actually geofences that operation and prevents certain roles from performing that operation from certain geographies. Because we are disassembling each of the requests in order to understand it and subject it to authorization, we're also able to have custom feedback to the user to explain the result of policy failure. So in this case, what you're looking at is an error message that's been customized inside the 365 admin console as a result of that triggered Cedar policy statement. Okay, very different context, but also a very important context. We keep a lot of the world's most important information in databases, of course. And let's say we have an example where we're concerned about data exfiltration, potentially, okay? So I've got a statement here that fully specifies I'm interested in the customer table within a particular database. But in that context, I want to permit the operation, but I want to have a few side effects. So what you can see here is those annotations just fit naturally in with the Cedar policy statements. The policy statements identify what operation has these side effects, and then those annotations, which are custom to StrongDM, have an effect on the result set. So in this case, what happens is we're instructing the system to redact a particular column, and we're instructing the system to limit the result set to, in this case, 4 rows. Okay, so regardless of what tool I'm using, I might be using Tableau or a Jupyter Notebook or a Rails application, the result is that both of those side effects take effect, and as you can see, the email addresses are redacted and the row count is reduced. Another example for folks that spend time on the command line. In this case, we've got, generically the SSH protocol. We are understanding it, and we're understanding furthermore which commands are being executed. And so we're able to intercept attempts to, for example, perform sudo and then subject it to additional constraints. So this may be familiar to some of you, but anyone out there, if you've got an MFA that's sort of difficult to wedge into one of your existing systems, using Cedar and using StrongDM might be a way to do that. So the result of this is, as I perform that sudo operation, I'm going to get a push notification on whichever MFA device I have configured, and only when I tap that approve are we going to see the result of that sudo operation. All right, so taken together, all of us right now are participating in this transition from an era of, macro authorization, maybe at role level, maybe even at the account level, to an era where we can begin to expect more out of our systems. We can expect that we can perform fine-grained authorization, real-time authorization, and see the effects of those changes in policy in real time, see the effects of those changes in context in real time, so that as changes to the user properties or the device properties or the time of day, as those take effect, they actually change the contours of what's possible within the product, all while generating really useful audit information and signals for threat detection systems, SIEMs, and your security operations center. In terms of StrongDM's particular implementation of this concept, one extremely powerful property that this gives us because of the proxy is it allows brownfield applications that weren't designed with fine-grained authorization in mind to begin to subject activity within those applications to fine-grained authorization. Because we're decoding the actions within the proxy, in addition to traditional PDP calls, we can perform these constraints, and you can begin using policy today, even if it's for a code base or an application that you don't control. And same goes for introducing MFA. So if you've got a system out there, you've got a database out there that's maybe on-prem somewhere, brownfield, just can't keep up with modern authorization, we're going to help you do that. We're going to help you do that with the Cedar language. Because of the richness of those signals, when you put it together with threat detection systems and the data lake that is bringing together all of these signals, you're going to have that fine-grained authorization that's then going to feed back on your policies and help you generate exactly the right policies to control exactly the right workloads with that full visibility and precise control. And that's our approach to continuous authorization, and so much of it is made possible by Cedar. So thank you again to the Cedar team. All right, next up, Abhi.
Thanks, Justin. That was a very good example of trying to authorize requests without having to rewrite the application by essentially doing what we call being a bump in the wire. For example, sitting as a proxy in between the database and the application and authorizing requests there. But we often come around situations and applications where permissions are a core part of it. I'll give a few examples. Let's say you're building a banking application. Well, who can withdraw money from an account? Or in a sales application, who is allowed to view certain customer orders and update them? Or in the case of AWS, within our training platform, who's allowed to schedule trainings, right? These are answers that you want an application to be able to answer. These are core to the application. Well, when we have to build these, what do? How do we solve that problem per se? Now, how many of you here are developers who have actually seen this and tried to build an authorization for this within the application? Well, I've seen a bunch. Well, our answer as AWS to that problem is Amazon Verified Permissions. We see it as a fundamental building block of building an application for authorization and permissions management. This is similar to how customers use an identity provider today for user management and authentication. So how does it work? How does your application interact with Amazon Verified Permissions? There are two ways that happens. The first way essentially is every time a user takes an action, the application calls Verified Permissions to check whether that action is allowed or not. And the service will give an allow or a deny decision. Well, how does the service take that decision? Well, the way it does it is by checking a set of Cedar policies that it manages. So that's the second way in which your application interacts with Verified Permissions, by creating and managing Cedar policies with Verified Permissions. Daniel here, who is a AWS hero and also a developer himself, had a use case at Simply Business where he had to control access to APIs and needed authorization for it. He used Amazon Verified Permissions to solve that problem. And I'll invite him up on stage to quickly talk about how he did through. Thanks, Daniel.
So before I will go into the specific implementation of our use case for role-based access control, let's focus about Simply Business itself. So first of all, it's one of the largest UK insurance broker. It provides fast, flexible cover for small businesses and landlords. As it's all about insurance policies, it's a regulated industry. And we're running all of our workloads on AWS. So why Simply Business exists? So Simply Business helps small businesses by providing insurance policies so they can help them to strive and achieving big dreams. Moreover, Simply Business believes in full power of small businesses. They provide insurance policy made just for them, so they can just focus on growing instead of worrying about different aspects. So let's focus on our use case. So what problem do we need to solve? We have some partners which we onboarding, and they accessing API gateway, and then the traffic is spread across multiple resource servers. So to make authorization, previously we implemented the way that on each and every resource server we have authorization, which isn't the greatest idea, and we wanted to solve it. But before, let's focus about we're talking about the authorization. We need to talk a little bit about authentication. So first of all, partner. Partner is an identity who's trying to log into our authentication service. Later on, we do the handshake with Amazon Cognito. So we need to validate our user in the user pool. You might think, why you just don't use Cognito itself? Because of the limitation of Cognito in different aspects and missing features, so due to that reason, we done it this way. Later on, what we need to do is to make a request to our identity service when we start roles from our users, so we need to fetch it. And in the end, we can generate the access token for partner to be reused later on. So what is the authorization requirement? What we would like to do is to send, for example, we have operation to renew insurance policy. We would like to send it to API gateway. And on the API gateway level, we would like to do the proper authorization. So later on, we can continue with our flows as in previous case. So what are the challenges? So first of all, as we have many resource servers, we have repeated authorization across multiple resource servers. And also, the authorization is only on the resource server level, and we would like to do it on the API gateway level, which acts as a front door to our applications. So what is the goal? To centralize authorization and also to have authorization on the gateway level. So how did we use Amazon Verified Permissions? So we use it on the API gateway level via AWS Lambda authorizer. Additional parameters like roles, which is stored in our JWT, so within the access token. And our example role is like partner A, partner B, and C, and so on. So how did we use Amazon Verified Permissions? So before the request reach API gateway, the Lambda authorizer is invoked so we can run some custom logic, and this logic is making requests to Amazon Verified Permissions. So we're making authorization request to Amazon Verified Permission, and in return, we will obtain authorization decision. So we can check whether we can allow or deny access for the particular partner. With that implementation, we have role-based access control on the gateway level, and we don't need to do it anymore on the resource server. So let's check what is inside the Lambda authorizer, so within the Lambda function. So first of all, we need to decode the access token because we need roles. Secondly, we need to validate JWKS, so by making requests to authentication service. Then we need to construct AVP payload, so we need to send information about entities we have, action which we would like to do, also send the roles, and so on. Lastly, not least, we need to make a real request to AVP, so it is authorized SDK API operation, and in the end, we just need to enforce authorization decision, so either allow or deny. So on Friday, there was a release of OIDC support for AVP, so what we can do here is to get rid of some things which we already done in the Lambda authorizer by connecting our OIDC to AVP. So we can get rid of decoding the token because AVP will do it for us. Also, we don't need to anymore validate the JWKS because AVP will do it for us. So with OIDC support, we can just construct AVP payload, make authorization request to AVP, but this time we will use isAuthorize with token. So besides sending the AVP payload, we also sending access token, and in the end we just need to enforce authorization decision. And now let's focus how we will authorize. So first of all, we have partner. We need to treat it as an identity, so principal. Then we have some resource, which is API endpoint, and the operation which we would like to do, so get, because it's HTTP method. The same will be for partner B. The resource will be the same, but the operation, it's posts, for example, to create something. So now let's focus how we need to set up it in Amazon Verified Permissions. So first of all, we need to have schema. Schema is a JSON data structure with information all of entities we have, attributes, relationship, even the data types. So it's also the validation layer for all attributes we have, entities, and so on, before we make a request to Amazon Verified Permission and obtain the authorization decision. Third thing is also that is the validation layer for policy. When we would like to try to create the policy, it will check it against the schema, whether all entities are in place, attributes, and so on. And last, it's also some kind of documentation for developers. Imagine you're working within the team, you have multiple applications, and for each and every application, we have different authorization rules. So we can easily check it with schema, so it's easier to cooperate together. Now let's focus on policies. So for Simply Business, the developer experience is very important. So how we can make sure that there is no learning curve when we would like to add some authorization to the specific endpoint. Do I really need to learn some Cedar language? Not really. What we've used is the policy templates. Policy templates is just the draft or structure of policy definition, which is reusable. So we can just define it like in the picture, that we permit specific principal and resource to do specific action, and just pass the principal and resource dynamically. This dynamically means that we can use template link policies. So eventually it will look like this. So it will create the template link policy that we permit that principal, which is in the role of partner A, can do the action of get on a specific endpoint. But you might think, okay, but I still need to create those policies, so I need to learn some Cedar, isn't it? Not really. What we've created is the configuration JSON. So for each and every partner and HTTP method, we create the separate JSON files, which looks like this, that we need to provide the objects of endpoint and role. And later on, our infrastructure as code, which is Terraform, will create it automatically for us. So it will map the data from the configuration files, and during the CI/CD processes, it will create access policy for us. So for us, there is no learning curve. You just need to submit pull request with this object, and that's it. Easy as that. And now let's talk about caching, because it's also an interesting aspect if we are working in organization. So typically, without the cache, what we need to do is to make request to API gateway, and each time it will invoke Lambda authorizer, and Lambda authorizer will ping AVP with authorization decision. That's easy, isn't it? And what we can do instead, we can use the native integration of API gateway, which provides the authorizer caching. So instead of each and every time making request to the gateway, we can use cache. We've set up the proper TTL and cache key. So it will read from cache, and if it will be expired or there is no cache, it will just invoke Lambda authorizer. So how we set up it? So first of all, the cache keys is access token, HTTP methods, and resource path, because we would like to avoid the situation when we only allowed get endpoint, somebody will use pause, but the response will be already cached. Due to that reason, we need to be careful with that. And for TTL, we set up for 10 minutes. So from the New Relic logs, what you can see, which requests were cached and which were not. So you might think, okay, so Daniel, how many percentage of that you can cache? So in our case it's 70% of calls to AVP are cached. And on the left side, you can see the gateway configuration with that. Now about the latency. So a single call to Amazon Verified Permission is authorized, so the operation for making authorization requests takes between 25 milliseconds to 40 milliseconds, which is quite good result. We really enjoy it. We also have distributed tracing because we would like to trace everything what is happening in the Lambda function because it requires a couple of steps. So the whole journey is captured within the spans. So we can check how many times it takes to make requests to our authentication service, also to AVP. So later on, we can check whether we can somehow improve it or not. Also, we created some dashboard in New Relic because each time when we onboarding new partner, when we changing some access policies, it will be nice to check, okay, how many deny or allow access we have. Maybe we've done something wrong. Maybe there is some misconfiguration. So having dashboard like this, when you build it yourself, is very useful. Also, the crucial aspect is auditability. So as a reminder, Simply Businesses operates in regulated industry. So we have a lot of regulations. Hopefully, with Amazon Verified Permission, out of the box, there is a feature of cloud trace. So all API operations are tracked and sent over to cloud trace. So whether somebody create a new policy store, delete policy store, edit policy store, all information will be there. So we can double check that. Also with of params. Also, if somebody try to authorize, we can see all parameters over there, which is very useful. So what next? So as we have role-based access control, now it's time for attribute-based access control. So in here, we can see our airbag policy. So to add some attribute-based access control, we can just use the when clause and add our information. And for now is everything regarding Simply Business. Now I will pass mic next to Abhi.
Thanks, Daniel. There was a good presentation and use case on how you use verified permissions to implement authorization within the application where permissions were a core part of it. But just rolling back a bit, we launched this service about a year back. We were there at Inforce last year down in LA, so on the West Coast, and we had launched this service. Since then, we have heard a lot from developers, from people like yourselves. And one question that keeps coming up is, how do I get started? People ask this in different forms. Some people ask, do I need to rewrite my application? What changes do I need to make? Do I need to learn a whole new language before I can even get started with the service? Some people ask, do I need to update a Lambda authorizer for those who are using serverless? Well, we realized the fact that we do need to do better in helping people get started. So on that theme, a couple of months back, we launched a new quick start wizard. Using this wizard, you can secure API gateway APIs without having to write any code. So what you can enforce is only users in authorized groups are allowed to access certain APIs. And then you can then easily extend that to then make it more fine-grained based on user attributes, resource attributes, whatever you want. The beauty is you don't need to write any code. It just works out of the box. Hopefully we see 6 red crosses on Daniel's slide next time once he's iterated with it. Underneath the covers, the wizard is automatically configuring your Cedar schema, your policies, the necessary Lambda authorizers, and so on and so forth. We're very excited that on Friday, we extended this wizard to support tokens from any OIDC provider. So this allows you to bring your own identity provider and then leave the last mile of authorization and integration back up to us. So we'll do that bit for you. Right? We're also excited today to say that we've partnered with 3 leading identity providers for this launch. So we've partnered with CyberArk, Okta, and Transmit Security. And during launch, we have worked with these partners to test and validate that their identity provider works with this feature. So rather than talk about it in more detail, I would love for Daniel to come up on stage and share his thoughts as an AWS hero and developer who had preview access to the feature and see how he built it. He'll also show a quick demo at the end.
Hello again, this time as security hero. So let's think about some use case with external IDP. So previously, when you would like to use Amazon Verified Permission with some identity source, the only option was Cognito. This time, as you can see on the previous slide, it has changed. So let's create some use case. So let's assume we have some user, and this user would like to access Amazon API Gateway, and we created some API. Let's call it loan API. So we have two endpoints, one for the creation of loan, and the second one is for the approval, the specific one. But the change will be here that we have Okta as identity provider. So what will be our goal is to create some role-based access control based on groups. So let's focus on the demo now. So we are in AVP console, and we would like to create our authorization engine. So we're starting from creating the policy store, so container for our policies. So let's click it, and how we can do it? We can do it manual, but also we can do it that with existing API gateway and external OIDC. Let's select this option. So and we can continue. So first of all, we need to set up the configuration for API gateway. We need to select some existing API gateway. Then we need to select the deployment stage. And what is important, we need to import this API. So one is imported, we can see that it's mapped from our HTTP methods, so two endpoints post with two gateway resources, and it will be mapped over to the Cedar action. So there is no learning curve of learning Cedar here, because it will automatically translate it into the Cedar language. So later on, we'll be focusing on the OIDC provider. So we will create identity source. As the default selection is Cognito, this time we will use the external OIDC provider. So what is important here, we need to prepare, obviously, the OIDC provider details by providing the issuer URL. I prepared the demo with trial on Okta. Then we can select the token type as we're using it from the gateway. We use the access token, but it will also work with identity token. Then we can set up some token claims, and then we need to set up the user and groups token claims. We use it untouched because it's the way we would like to, sub and groups. We can also set up the audience validation, but we don't need to. Later on, we need to set up groups. So we'll create two groups. One will be loan creators, which will have access only to create loan. And the second group will be for officers for loan, which will have access to all of the API operations, so only two of them. Then we can continue and deploy our app integration, so API gateway integration. So we can select the option whether we would like to do it later. So first we will attach it to the endpoint which we need or want, or we can use the option with now. So all API endpoints will be there. So it will create API policy store. It will also create the Lambda authorizer for us. And in the end, it will attach authorizer for us to the gateway automatically. So let's continue and create the policy store. What we can see, we created policy store, identity source, schema, to access policy, and also deployment of CloudFormation template, and also attachment authorizer is in progress. Obviously, we need to wait like a couple of minutes for that. But let's check what we have for the created policy store. First, the schema. So we have principal as user. We have two action for our ATP method, and the resource is the application. And now let's check our policies. What we have is the two policies. First policy is that we're checking that principal is in the user group of our OIDC provider, and also it's within the specific groups, and it has access to action of creating the loan and also for approval the role for the any resource. And the second policy is almost the same, but with different action and the group. And now that's all from the demo, and pass mic to next person.
Thanks, Daniel. So that's it for this session. Just as a little recap of what we went through, the problem that we set out to solve, and by no means are we finalized solving it, but we believe we're making some great progress, is to enable organizations to implement consistent authorization across their organization. And the key building block that we've provided to enable organizations to do that is the policy language Cedar, which enables organizations to write policies that describe the authorization rules, the rules that describe who is allowed to take what actions and what resources. And we saw how StrongDM have used the Cedar policy language in their product to implement use cases such as determining what data a user is permitted to bring back from a database. We also touched on Amazon Verified Permissions, which is a hosted service from AWS for the management and evaluation of policies. And we saw how Daniel at Simply Business is using Amazon Verified Permissions to protect APIs for insurance policy management. And lastly, we demoed a new feature that we've just launched, which enables you to connect your own identity provider, and we support any OIDC compliant identity provider, into Amazon Verified Permissions, so that Verified Permissions can evaluate a request based on a token that's generated by that identity provider. And that token may contain information about group membership, it may contain user attributes. So thank you very much. Greatly appreciate the time you spent with us today. And the team, myself, Daniel, Justin, and Abby will hang around at the end if you've got any follow-up questions. Thanks.